Welcome back. On this part, we're going to be covering error handling, and in particular in Java, that means using exceptions. So Java supports a lot of different types of exceptions. You can even make your own exceptions, so I'll omit that for now. Basically, an exception is an interruption to the normal control flow of a program. In other words, when something out of the ordinary happens, so an error condition occurs, an exception is raised, and we call that throwing an exception. And then your program can choose, in some instances, to catch that exception and then handle that exception. This is in contrast with defensive programming. Defensive programming, you look before you leap. You check, am I about to do something illegal, or is the operation that I'm about to perform, say, dividing by a variable, and that variable is 0, division by 0? Am I about to do something illegal, and so I should not do that, and I'll do something else, which is a simple if-else condition? Or with more modern programming languages like Java that use exceptions, basically it's go ahead and leap before you look, because even if you fall off the edge, it'll catch you and return control back to a point where you can actually handle that exception. In Java, there are actually two types of exceptions. There are checked exceptions and unchecked exceptions. Checked exceptions are exceptions that you have to handle in some way. So the usual way of handling these is to surround them with a try-catch, and we've seen that in previous videos. Or you can add a throws declaration, which I'm not going to go over because that's not the best way of handling them. Instead, I'll show you what to do. An unchecked exception is an exception that you can choose to surround it with a try-catch or not surround it with a try-catch. In other words, you can choose to not handle the exception, in which case the exception continues to be thrown up the call stack until you get to the very first entry point, the main, at which point it becomes a fatal exception and it kills the entire program, which is 99 times out of 100, that's actually what you want. You can't reasonably recover from these exceptions, and therefore they should be made fatal. So I'm going to show you both of these in one example, and I'm going to also show you how to deal with checked exceptions in practice. So what I've got here is I've got a piece of code set up to open up a file that does not exist. You see over here in data we've got input and output.txt, but we do not have a foo.txt. And so like we saw last time, when I create a scanner to read from this file, I was forced to surround this with a try and catch block. In other words, I'll try this dangerous code in here, and if something happens, like the file doesn't exist, that's okay, because the system, the scanner, or some other part that's not in this immediate vicinity of this code is going to raise an exception, throw an exception, and in particular a file not found exception, and then I've got a catch block here that if that happens, then I will go ahead and handle that here. The way that we handled that before was by printing a stack trace and then doing nothing. In other words, then the program would continue normally down here, but of course there's no code, so it would end up doing nothing. But otherwise, the other way that you can handle this is by catch and release. If you're trying to open up a file that doesn't exist, how can you reasonably recover from that situation? You could create the file, but then what do you put in the file? If you were in a graphical user interface, you could say, oh, that file doesn't exist, please choose another file, and then bring up a file dialog. But using modal design, in other words, restricting the options that a user has in a graphical user interface program, that would have prevented that error anyway. So there's no real reasonable way that you can recover from a file not found exception. So I'm going to rethrow it, and I'm going to throw a new runtime exception. A runtime exception is an unchecked exception. You can choose to surround it with a try-catch, or you can choose not to, in which case it'll become a fatal exception. So let me go ahead and run this. And of course the file does not exist. So we're going to get that exception. Runtime exception, it's a file not found exception. Data foo.txt does not exist, right? And you see the entire stack trace here also being printed. That's what we kind of had last time, where we just went e.print stack trace. Now a lot of other stuff could go wrong. For example, let's go ahead and create that file so that this exception no longer happens. We'll go ahead and leave it empty. Actually, I'll go ahead and put in hello here. Right. Now let me go ahead and run this again. And a different exception comes up. A number format exception comes up. In other words, this first line here is no longer dangerous. Well, it is still dangerous if the file doesn't exist, but the file exists, so we go on beyond that. We read the first line, which contains hello, but then in line 22, we try to convert that to an integer using integer.parseInt. Right? The entire line, we're trying to convert that to an integer. Well, obviously hello is not an integer, so it throws this number format exception. Note here that I did not have to explicitly catch that exception. That's because it's an unchecked exception. I can choose to catch it and deal with it, or to let it be a fatal exception like it was here. It killed my program. It didn't go on to the next line, say that I'll put another line here. This will not actually get printed because it interrupted the normal control flow of our program, and nobody caught this, or there's no code here to catch this exception, this number format exception. So it just kept bubbling up. It went all the way up to the main method, right? And in which case it became a fatal error. It killed the Java virtual machine entirely. You can choose to catch. I chose not to catch this exception. You can choose to catch it. Now I could use the same variable here, e, but to distinguish them, I'll go ahead and use NFE for number format exception. If you wanted to, you could go file not found exception and use that here. And I could choose to do something different here. For example, if I wanted a default value, x would be equal to 0 instead, in which case I'll have to change the scope of this. So in this case, I'm choosing to handle it differently. If I can't find the correct number in the file, then I'll go ahead and use 0 as a default. And you'll see here that you don't get the stack trace anymore, because even though there was an exception thrown, control was given down to this block here because it was a number format exception. I didn't rethrow it. I didn't echo any error message. I didn't print the stack trace. I simply chose a default value of x here. The program went on and used that default value. If I actually had a number here, 1,234, then it would end up using that, because in this case there's no exception at all, right? Now you can have multiple catch blocks. And the order does matter. It's like an if-else statement. The first one that matches is the one that gets executed, and they are all mutually exclusive. There is a catch-all. Every exception, every type of exception is an exception. Like a file not found exception is an exception. A number format exception is an exception. So if you just wanted to catch any other possibility and rethrow it as a runtime exception, you could do that as well. So again, you can define your own types of exceptions if you really want to. I will omit that from this demonstration, but that's how you do basic error handling in Java.